Good morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our expert panel on unveiling hidden patterns, revolutionizing predictive models with generative AI-driven feature discovery. It's a mouthful. Brought to you by our friends at Data Robot. I'm Amelia Mink, CEO and founder of Data Science Connect, also known as DSC, the world's largest data science community. Today, we're excited to welcome hundreds of attendees from all over the world to discuss how Gen AI is reshaping feature engineering, automating the discovery of key variables, and elevating the performance of predictive models. Today, you'll learn how Gen AI can automate or enhance feature engineering processes, practical tips of integrating generative AI into feature engineering workflows, and which skills, roles, and technologies will be essential in this new era of generative AI. We are honored to hear from a distinguished panel of experts today. Our moderator and longtime friend, Dr. Francis Boykin, Director of Advanced Analytics at AT&T. Jessica Larson, a senior software engineer and author who has previously held roles at Instacart and Pinterest. And Jess can include a link to her book in the chat, either during or after, so you guys can check out her book. Dushyant Singh Singar, Director of Data Science Advisory at BDO. And Jonathan David Shake, Executive Manager of Data Models and Strategy at Grant Thornton. We'd also like to thank our partner, Data Robot, for making today's panel possible. Data Robot's AI platform and their channel partners accelerate AI adoption and deliver tangible business outcomes for their customers. You can start your free 30-day trial at datarobot.com by clicking on the link below, so at the button below, and you can do that throughout the webinar as well. And before we begin, we have a few housekeeping items to consider. To make this a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and any other information you want your fellow attendees to see. Also, please take advantage of the Q&A and chat features throughout the talks. We're dedicating a portion at the end to Q&A, so be sure to upvote the questions you'd like the panel to address. Now, without further ado, let's kick off our panel.
Thank you so much, Amelia, for that great introduction to this wonderful panel. I'm going to jump right in because I know that we're going to have a lot of conversation and a lot of questions and answers at the end. So let's just jump right in and ask our panelists if you could just give us a little bit about yourself, your background, and your current role. And then let's try to keep it to about 30 seconds so that we can be sure and get to all the timely and wonderful questions that we have. But if we can go ahead and start with Dushyant, that'd be wonderful.
Absolutely. Thank you so much, Francis, for the opportunity. My name is Dushyant Singh, and I'm a director with Valuation and Capital Market Analytics practice with BDO here in the Chicago office. I head up the model risk management and the product development and innovation practice here at BDO.
Awesome. John?
Me?
Yes.
Hi, I'm Jonathan David Scheik. Thank you very much for the invite. Nice to be here. I'm a data scientist. I've spent 14 years of my life in banking and financial services in areas of risk management, portfolio management, and data modeling for regulatory risk compliance and controls. Nowadays I used to work for Grant Thornton. Formerly, I managed their strategy for data models. Today, I've started my own venture called Savios Data, where I basically help companies discover new patterns and predictive models with their data. And been doing that for the past 2 years.
Amazing work. All right, Jessica.
So my name is Jessica Larson. I have a background in cognitive science and computer science. And I've spent basically my entire career in data analytics. I started more on the data science side, eventually moving over to data engineering, and most recently did a stint of, more pure software engineering. I wrote a book on Snowflake access control because I am a bit of a data privacy nerd. And right now I am just, working on my next book and working on some personal projects. And I guess formerly I was at Pinterest and Instacart.
Amazing. And again, I'm Frances Boykin. I'm a director of advanced analytics at AT&T. Today, I have a team of folks that includes data engineers, including some of the feature engineering for our AI services. We prepare and develop the backend services for our Gen AI organization, as well as produce some customer experience analytics and data as well. Right. So thanks to everyone. So let's start with the basics. Can each of you tell us a bit about what feature engineering is, why it's important in data science, and provide some examples, if you have them, of how you use feature engineering within your organization? And we can start with Jessica.
Immediately lost my mouse to mute myself. Yeah, so I think at a super high level, really what feature engineering is paring down to a smaller set of features that's actually important. I think the biggest reason that this is really important for pretty much anything that you want to do with data is it's really expensive to look at everything all the time. And it's also really impractical. You can't really action a lot of things if you're looking at literally everything all the time. You need to be able to look at a defined set of things that you think are important, which also gives you a little bit more ability to insert some policy into your models and all of that as well. I guess it's like high level.
I can share my high level view as well. I see feature engineering as sort of before you go to a great gala and you look super nice and super dapper. I see it as taking a shower and being very clean, right? And so before you put everything you put on. And just like Jessica was saying, to me, feature engineering is getting the data set ready, right? And getting it down to a set of values or set of things that are actually important for business. So I think there's a technical standpoint on it, and I think there's a business standpoint on it. From the technical side, I think it's featuring everything so the data set is ready for that business goal. And then I think the other phase of feature engineering on the business standpoint is getting the people ready to understand what is it that you're going to do organization-wide, and why is it important to do the feature engineering before you build or conduct any modeling whatsoever or bring any results. So I think there's two sides of feature engineering, one technical and one business.
And go ahead, Deshaun.
So I just wanted to share my thought. I think I completely relate to what John said, and Jessica, thanks for. I like to see feature engineering, or like to call feature engineering, as something that you resort to when your models don't work. What I mean is, everybody, back in the day, people used to do model preparation, model data preparation, right? That was the feature engineering term wasn't there 10 years back. It was a simple model data preparation, put it in the model, then you tune the model may or may not work to your liking. Now, this is when you want to go back and do additional work with the features. That has over the time scaled in requirements, everything, because now the models are changing fast. So there's a need to be more agile with your model data preparation. And I think that's how I like to look at feature engineering. That is the term. The reason why we associated that engineering with simple data preparation that used to do with SQL and some basic steps. Right. So yeah, in my mind, that is how I like to look at feature engineering in today's world, because things have scaled up drastically.
And I think to all of your point, it's the paring down of the data. But from my side, where I work mostly, one of the other great things about feature engineering is, now that you've engineered these features, we can now reuse them across all of our organizations, and we know that we have the right features to work with. I think that's one of the integral parts about doing that upfront prep. and then making sure that those features are now kind of the solid ones that we know we want to use for certain analytics and supporting the business, as you say. So all very, very great pieces there. Have you had some opportunity to utilize feature engineering within your own organizations where there have been specific projects that you've had said like, hey, we've got these features now that we want to leverage for specific parts of the organization? Has anyone had that? Well, it kind of makes sense that you might want to leverage them that way.
So when working with experimentation, we would typically have like a set of features that that we want to basically measure against all of our different experiments. And sometimes that might map to like a particular domain. So, maybe if you're working with user signups, you might have some features that measure how often people are finishing the sign up process, how long it's taking them to do this, things like this, right? That you really want to be able to measure against every single change that you ever make that touches that flow of somebody signing up, and basically saying this set is for this domain, this set is for this domain, and then you might have some that are for the entire organization, just to basically make sure that if you're trying to fix one problem, you're not creating 10 others, or you're not ruining some of the hard work that we had already done to get us to this point.
I have maybe a real life example on feature engineering that I've used in the past that I may share. So I think when we talk about data science and future engineering, it can be a very broad concept. But if you actually take, what specific industry you're talking about, what specific activity you're talking about. In my experience, I was in banking, and I was building what they call probability of defaults models, or loss grade defaults models, which is basically taking a look at a set of borrowers, people who actually the bank is going to lend money to, and understand whether those people are going to pay you or not. In essence, that's what it is. And so you take a set of features, right, that are known to the bank, which are, for example, the financial statements. And you can predict whether or not a set of borrowers are going to pay you or not, and what scale. But if you want to add more features, that is, if you want to engineer more features to that model that are away from the financial statements, and say, for example, it is, let's say we're talking about a portfolio or a business relationships within a real estate lending portfolio, and you want to take the feature of payment of taxes, and you want to integrate it into the probability of default model. Well, that feature engineering, right? It's engineering how to get that data set and bring it to this data set to calculate the probability of default. And that featuring has to be guided by parameters that it only works within real estate portfolios across the bank. So we feature engineer that specific category only to apply to real estate portfolios of the bank. And so feature engineering can be helpful on, at least in my area of expertise, which is portfolio management, can be helpful to adequately create models for specific type of assets, specific type of portfolio, and then put the limits as to in what portfolios this won't work when we calculate probability of default models. So that's a real example of how I have done it.
I would like to add, I think, just piggybacking on what John said, in the world of probability of default kind of models, there are all the different data sets that you want to utilize. And those data sets, if you're talking about a large bank, like $10 million plus kind of banks, you would want to have these different data sets ready to be used across departments, right? So that's when these data sets, in today's language, there's another term called data products that are created, so you can use these data products readily or maybe data mesh in some cases. That's what it is also called. So these come to your rescue a lot of times, not just for model training, but even during inference time, because you need readily available data during inference also, model inferencing, right? I think so from that perspective, this does help. Maybe I can quickly share one example in the space where I work currently. I used to be on the banking side, but now I work on the capital markets, wherein you receive a lot of information around your bank statements, income statements, market prices, all of that information that comes in from vendors, right? So most of the times you need to be able to standardize this information before you feed them into the models. So it's good to know all these features beforehand and make them ready to use. I think that's where the feature engineering component helps a lot, since data moves fast. So you need to keep that data ready to be consumed by models, both in training and inference stages.
And I think one last comment on, also piggybacking on Dushan's, is you have to really define your target before you do any feature engineering, and understand that from a subject matter expertise on that target to really get the features that you need for that model. I think we can speak about feature engineering. It's a very, very broad concept, but to bring it down, I think you have to really define what is it that you're trying to do. What's the business purpose? What's the impact of this that is relevant to this feature engineering?
Awesome. So I did miss one thing that I want to say right now, and that the panelist commentary does not reflect the views or opinions of their respective organizations. I should have said that at the beginning, but I want to make sure that I get that in there as well. So thank you so much. Great comments there. So another question. What are some of the biggest challenges that you face with feature engineering in your organization, and how are you addressing those challenges today? I know that feature engineering is a big part of any of your AI projects, any of your modeling projects, your analytics projects. Feature engineering is a big piece of that. So I know that based on different organizations, you may have different challenges that you face. So anyone can jump in here, but if you have some of that information, I think that'd be great for our audience as well.
To me, if I may start, and maybe you guys can follow up after me. To me, the biggest challenge is not a technical challenge. It's actually a people challenge. It's a data literacy challenge. It's making sure that I place everybody that is working in the model, or that it's going to get the end result of that model on the same page, and they understand and speak the same language on the people side, and why any feature that I'm bringing into the model, why is any new feature that I'm bringing into the model important to them. So I think the biggest challenge for me right now in the industry, and I see it industry-wide, it's really on the technical side, having subject matter expertise of the business side, and on the business side, having technical understanding on why this is important. So I think my biggest challenge is, and so the biggest challenge becomes teaching, and it becomes making everybody aware and be on the same page, same level of understanding as to why we're featuring data this way. And that takes a lot of time. If you're going to build a model, you're going to build it in a month or two, you're going to add another month or two to build it, because you have to get everybody on the same page. And that's the biggest challenge for me.
So John,
Yes.
does that kind of sound like standardization? Because one of the things that I found is that one team considers and calculates churn one way, and another team calculates and sees churn a different way, and getting that standardized, hey, this is the feature that we want to use across the business units based on everybody's different, need is a struggle. So that's kind of what I heard from what you said. It's as well, it's getting everybody on the same page, getting a standardized view of what these features are.
I agree. Yeah.
100%. That's what I also hear. That's a challenge, getting everybody, like two different teams may define the same variable differently, right? And then especially this example of probability of default. This is a target variable. And if you're trying to define this probability of default, it could be done in different ways. So that's one great example. From my perspective, I would want to add a different challenge that I often come across, one of which is data availability, completeness, and accuracy. Because in my world, in capital market and analytics space, there is, I would say, data sparsity or data scarcity. There's data that comes in, and then there's data that often comes with a label that you cannot use it for various purposes. So I need to be able to work with legal and all that, make sure that everything that I'm using, like a lot of times we talk about in the banking space specifically, that data, you cannot use all the alternative data sources that are available to you, right? Before, you need to make sure they have a green light from legal compliance and everybody before you throw them into a model, right? So that's a big challenge. Feature engineering, it helps with, from a technology perspective, all of that is great, but you need to also understand the implications of using that data. So that's another challenge. That's my first step. Every time I want to use a variable, I need to be able to make sure that is usable.
Amazing.
And I just kind of wanted to add on to what John, you were saying, and then Francis, kind of what you were saying about standardization. I think that there's a big component of this, like we've kind of outlined, like it's not necessarily the technical piece, but there's really a lot in the operational like the operational component is like a big piece of that. And it goes a lot further than just like standardizing these metrics and making sure that the teams are using the same ones, but also the governance, who is actually maintaining these things, who decided that that is how we're going to standardize them. But I would even go one step further and say that a lot of the decisions that are made at the very, very top of the company. So when we're looking at CEO, CTO, et cetera, organizational thrash can completely destroy any organizational work that you have done to try to make sense of all the features that you have. I know I've worked in a number of organizations where we have reorgs all the time, and all of a sudden we have new teams and teams that are gone. And I think that we spent a lot of time trying to benchmark like individual contributors and try to put numbers to capture their performance and how well they're doing. But I don't think that we really do a good enough job of trying to understand what that looks like at the leadership level and trying to quantify things like, reorging and removing teams. Great. Who's going to take over all those features? You have all of this turnover, and now nobody's maintaining this. Nobody has any idea at this point, because the person who maintained it, they left, but the person that was on their team left too, right? And those types of things can almost affect your work stream more than the actual technical work itself.
And also, you bring up a good point there, Jessica, the models that have been leveraging those features. Who's maintaining and making sure that they stay succinct and up to date? If the features are out of sync, then the models might be out of sync as well. And then that presents a whole much bigger problem. Well, thank you for that. We do have a few questions that I've seen pop up in the chat, but I think I'll keep on through our questions, and then once we get to the questions and answers session, I'll try to go back through those. So, Dishant, there's been a lot of hype around generative AI, and organizations are starting to look at how generative AI can help automate and enhance their feature engineering process. What are some of the opportunities that you've seen for generative AI and how does that play a role in feature engineering?
So I'll give a quick response, but then I think this is a very broad topic. I would definitely want John, Jessica, you guys also to weigh in. So in my opinion, we talk about generative AI. There are a couple of different approaches, high level, which help you with generating synthetic data, is what we call it, because there's data scarcity almost every time you are looking to build a machine learning model. And I would want to also go back to my previous comment where I said, you build a model, then you realize probably you need more data to be able to get meaningful results, right? That's when you go back and see there is more data, which is meaning more records, or you probably would need more information, which is your variables, new information, right? So it again depends on what is the use case. So generative AI, I believe, I remember back in the day when I was trying to build a computer vision model, trying to recognize facial emotions. Um, uh, I had to scrape the internet for 1,000 images for almost like a week, and I still couldn't get the kind of images across different emotions that I was looking for. This was almost 4 or 5 years back using a basic Python script, right? Now I think that is easily doable. You can generate the data that you want. Let's say you're trying to build a model, you can generate those images. Similarly, in the case of text data, that if you're looking to get some more information, let's say it's a consumer complaint data, and you don't have enough records to train your model on, you can generate this text data from generative AI, right? So I think these opportunities now exist, and you can scale these as well, depending on the infrastructure that you have. So I believe these are some really great examples that I have personally now realized that are available, and you can use them. So this is one side where you're talking about unstructured data, but I definitely believe generating like tabular data is now much easier. You can try even chat GPT. It would give you a Python code to give you 1,000 records if you want to generate that on a fly, right? But these are some basic, if you want to do some research, these are great. But if you are doing some enterprise level data generation, then there are more clauses that you need to take care of. No more conditions in terms of accuracy, completeness, all of that has to be taken care. So generative AI is a great promise, but then let's talk about, I would say it's a more deeper conversation as you talk about building more responsible models, right? Because end of the day, while you're talking about feature engineering, it's the model which is generating the data. So there has to be risk management around the model that needs to be done. So I'll stop there, and then I'll let the conversation flow.
Yeah, I mean, I think my first thoughts whenever I think about using a model like generative AI or just large language models in general is that risk management aspect, and trying to make sure that whatever tasks that we're using has fits the bill as in terms of how accurate you need those predictions or that generation to be. Um, so, the first thing is like, where do you need a human in that loop, right? Are you having the generative AI generate a bunch of code that's actually running to create these models? Okay, cool. But, that might work for your organization, but where are we checking to make sure that things are complete or accurate? Um, I do think though, I guess maybe it's a little bit less on generative AI and more on large language models, but I feel like the two go hand in hand. I do think that there's some really interesting opportunities for feature engineering, specifically with unstructured data. I think when we're looking at structured data, we have that, I think, pretty well under control to try to find which features are the most important, right? When we have PCA, we have all of these others that I think do a pretty good job of determining which fields are interesting. But if we're looking at unstructured data, like I've commonly seen entire companies' wikis be used as context. or Slack messages or emails or the entire company's GitHub repository, right? And I think that then can probably be pretty effective to surface features that maybe are really important to the company because people talk about them on Slack, or find things that are in the code base a lot that, maybe that there's some features there that could get rid of that mess, right? I think that I don't know, I think there's pretty interesting stuff in the unstructured data piece.
I think in my view, and Jessica, thank you for that. I think in my view, with generative AI, we are on the beginning stages of it. I think we're just scratching the surface. And I can tell you that from a banking's perspective, where right now I see banking and financial services industry develop the teams around large language models, around what the generative AI can actually do. And I see generative AI as the great librarian. So back in the day when I was in college, you try to get a job at a library, right? And in the library, there's hundreds and thousands of books, and people ask you for information, and you're the person who kind of needs to know where that book would probably be, right? And you go to that book, find it, and that's how I see generative AI. So it comes back to what I was saying at the very beginning. You have to define what is it that you're trying to do well, and have the subject matter expertise to really use this generative AI to your advantage. And also, from what lens are you looking at, right? Are you looking at from a lens of a technician, from a technical? So I can tell you as a data scientist, even though I prompt the generative AI on my side, I still have to check what it means in my area of expertise, right? And in terms of a management perspective or a business perspective, generative AI, I don't have that technical knowledge, but I have the ability to know where I want this data, what I want this data to do. So I think it goes back to defining and subject matter expertise to really be able to use generative AI to your advantage. And I think we're still at the very early stages. And from what I see in my industry, the teams that are actually doing work on generative AI are being built as we speak, right? And we're trying to catch up to, okay, what can actually be done with this technology? I think that's where we are.
Awesome. And I will just add in just a little tidbit here from my perspective, again, from the data perspective and managing the platforms that house all of this information. A lot of the work that I've seen done in Gen AI is leveraging the prior work that we've done as well. So like you said, a lot of us are just getting started with Gen AI. Some of us just within the last year are starting building out these Gen AI teams and leveraging Gen AI and automating things. But what we're starting with in most cases is stuff we did. So stuff we did in other ways, traditional modeling work. So we're able to leverage the knowledge that we've gained from some of the traditional analytics and AI work into the Gen AI. So basically taking it to 2.0 for some of the projects that we've worked on. So I think that if you're out there and you're just getting started, that's a really good way to get started. Take some of the projects that you've completed in using other technologies or other ways of doing analytics and AI, and then kind of doing a 2.0 version of it, and then seeing how that goes. So awesome conversation there. So for organizations looking to integrate Gen AI into their feature engineering workflows, what practical tips and practices would you recommend to ensure a smooth and effective integration? And I know, Jonathan, you kind of gave us some of that already. Is there anything else you want to add to that?
No, I think I was very straightforward. But what specific? Are we looking for something specific, a specific example?
If you have some examples of how you've integrated Gen AI into the feature engineering workflow, I would say, for example, from my perspective, we have not. What we are doing, we separate it, right? So we have the feature engineering. Someone in the chat asked, do you have a repository for feature engineering? Well, my suggestion is that yes, you should have a repository for your feature engineering. That allows you to leverage it across your organization. And at AT&T, I can speak freely of that because we actually created a feature engineering tool and we sent it mainstream. So I can talk about it. It's not private. So yes, I believe you should have a feature engineering tool that you can now leverage across your organization. But specifically for Gen AI, I know that we have not integrated the two. We might leverage the feature engineering tool for some of those features, but we are still at the place where we're saying, hey, right now it's too, as Jessica said, it's too much data and too kind of wishy-washy. We'll just separate it out. And then we'll merge the two when we need to. So
I can tell you my perspective as a banker, and I can tell you my perspective as a data scientist. So from a banking's perspective, a lot of what's being done in data science and feature engineering is actually subject of debate, because when we use artificial intelligence and this large language models and this generative AI to bring new features into models, there's a lot of question about subject matter expertise in the banking world, and whether or not that technology is accurately bringing the data that's relevant for model development, right? So I would say on the banking side, there's a clash of schools of thoughts, because in banking there is the risk managers, right, who try to prevent things and are trained to say no. So they're trained to say no to the things that generative AI, in terms of what features can go into a model, is saying, right? From a data scientist perspective, and there's a lot of sensitivity on the privacy side of things, of what things are being done on those models. So I can't talk too much about those specific examples, but I can talk to you about, as a data scientist, how I have used it. And to me, it comes down simple as generating code for me and generating databases for me, so that I can test out models that I'm building on my own. But that's me as a data scientist on my side on how I'm using that generative AI to generate code for me, and generate databases for me. And in that it's an invaluable tool, because before we used to have to think about, okay, where is the database? I need to access it. Is it public? Can I bring it to my environment? And now generative AI can simply do sort of like a database for me and bring me the data, even though it's non-existent, but I can still test it out. So maybe sort of two views on that.
good points.
Francis, I would want to actually clarify. I'm seeing there's interesting conversation going on the side that I was just monitoring. And one thing I would want to clarify, that I think I made a comment earlier about being able to use generative AI. And then I also qualified it by saying it is not ready for enterprise use. It is most for research purposes. And if you're generating a data set that you want to use for any research that you're doing, it is great. But also, that was one part. But then there is something else that I want to also qualify, which was about, is there any specific examples? When we talk about generative AI, I think we are probably thinking right away about large language models. But then there is other kind of model. Large language model probably is just a decoder, which generates an output because it has already learned a pattern. There is another set of generative models, which is called GANs, Generative Adversarial Networks, which I think is very different from how decoder only model works, which is what it generates data, and probably it has learned it from everything that is available on the internet. And then you definitely would not want to use all that data for your enterprise grade work, right? So in that sense, I believe GANs are definitely a good option, because it is generating data based on some level of noise that is being inputted by a generator, which a discriminator is actually helping you discriminate between the real data and the synthetic data that is being generated. So I believe that is a good use case. A lot of enterprises do use that, because the way it works is we are not talking about unstructured data. Even in cases where you want to generate some structured information, you would be able to see if the generated data and your real data set are statistically similar in nature. And if they are also within the kind of range that you're looking your data for, then you can very well use that data for any kind of modeling work within your organization. So as we talk about generative AI, there are two types of model is something I would want the audience to know. One is definitely a GAN kind of model. Then there's other decoder kind of GPT models that we are llamas of the world, right? So you can use llama or you can use ChatGPT to generate structured data as well by asking it to give you a Python code to generate a random number generator, right? But that may not be the best way. But it is still, if you want that kind of data, you can definitely use ChatGPT or maybe Llama or maybe Mistral. But definitely go for GANs is what I would say. That's one use case I can share with the audience where generative AI and feature engineering can come together.
Thank you.
I wouldn't want to continue more, but there was another aspect of what are the risks associated with using models for generating data. But I would just maybe first let Jessica or John opine on that. I can definitely talk. I can go on and on.
Right. Any other comments there?
Yeah, so I was just going to kind of go back to the original question about like, what are the tips or whatever to practically implementing this. And I kind of wanted to call out what Mohammed had said in the chat about, exposing data for any regulated industry. With with the passage of GDPR, and in California, we have something pretty similar, CCPA, is the newest version. I think a couple other states are following suit at this point. There's basically not a such thing as not a regulated industry anymore. Everything is a regulated industry. Any company you work at, you need to be concerned about any internal data, whether it's about the company or about your users. You need to be concerned about that going to that model. Now, in practice, when you fork over some money, you can have your own separate model where your data is not flowing back. So I would say that has been, for the most part, I think, solved. The only note on that is that is not obviously the default. And so obviously you need to be looping in your security teams, et cetera, from the very beginning, so you do not lose your job and probably also some other penalties as a result. So that would be one thing I would say to keep in mind. The other big thing that I saw, I think James might have been the name who commented this, something about the cost of using these really, really large, robust models. Yeah, I mean, it is frequently you see a lot of these use cases where the actual product of all of the work probably does not even come close to making up for the cost, right? So I think coming in with really clear goals and understanding what you're trying to accomplish, and putting together maybe a success case that is also a failure case. So we hit this point and we're going to have to actually just wrap it up because that wasn't successful. I think that that's one thing that I've seen a lot are not a lot of in my career. I think we always want experiments to succeed. We always want to test our hypothesis and be right. But it's also just as valid to admit that you were wrong and or your team was wrong. Something was wrong, and it's time to just scrap it and move on and wind down that cost before it completely runs away or you're doing things that are making your product worse.
Awesome. And I will say, and I don't think I'm spilling the beans here, that AT&T has, of course, they forked out the money and they're using their own version, right? It just makes sense that we wouldn't be shoving our data into an open AI, chat. So, but all very good points. Okay, one last question before we get to the question and answer session. What skills, roles, or technologies are essential within the data science teams to effectively leverage Gen AI for feature engineering and predictive modeling? And I'll just throw that out there to the panelists and whoever wants to jump in on that question.
I always love these questions because I have had, I think, maybe 5 different job titles in my probably slightly over 5-year career at this point. So I love, I don't know, I love any of these questions. So I think when we're doing any of the new technology that we're looking at, whether it's generative AI or whether it's whatever is super cool in 4 years, most of the learning that we're doing is self-guided, right? We're going and doing some tutorials and looking through Stack Overflow and things like that. And that's fantastic, right? Like that's a really great way for people to be learning things. But one thing that can happen really easily when you're doing self-guided learning is not being able to answer that question of, I don't know what I don't know. And so I think one of the biggest ways that you can get ahead is looking for theory, right? To a lot of people, less exciting part. For people like me, the way more exciting part, because theory is really fun and interesting. But there's a lot of really great online lectures that can be leveraged, where it's not necessarily just one lecture here and there, but it's an entire course. I highly, highly recommend doing that. I think having the fundamentals and having that background and really thoroughly understanding what's going on is really, really important because there's always going to be new things coming up. And instead of being very focused on that particular thing, be focused on what differentiates that new thing from what we already have, right? What does this thing do better that everything else doesn't do as well? And as far as that goes, like Harvard, MIT, I think Berkeley as well, my alma mater, have lots of course materials online where you can do the entire course and really, really fundamentally understand something.
I can give some of my experiences. So what I've done in terms of to be successful or to bring things to fruition, right? I worked at a global consulting firm in New York called Genpact for about 3 years on digital transformation. And my job there was basically, just to give you a setup, we were bringing what's called natural language processing technology into underwriting and risk management, and just bringing that into different banks across the globe. And I worked with different teams in different countries, and some of these teams were highly technical, highly business, and it was a mixture of those. And I found some common denominators as to what you need to have in a team that's actually implementing new technology to actually carry out things and bring them forward. And especially because the circumstance that we're in now, we're being flooded with a bunch of new stuff, right? That can be very, very stressful. Not everybody has all the knowledge on the technical side of it. Not everybody has knowledge on all the business side of it. So to me, what was helpful is to go back to the basics, right? To sit in the middle, understand your circumstance, and really try to gain as much as technical expertise as you can, and try to gain as much as managerial expertise as you can, and try to collaborate and bring a collaborative tone to the team that's working on whatever endeavor you're working on. I think those are keys to be successful, is coming back to the basics, understanding that this is very new. It's very new for all human beings, this new technology. So we're going through a shock, and really have that collaboration mindset, because a lot of the things that I saw in these teams is that highly technical folks would tend to focus on the details of models, on the details of data, and business folks would focus on the client and how we're going to bring this to fruition. So to try to be that center, right, that brings everybody in harmony to bring whatever you're doing with generative AI, which is new, which is stressful because a lot of people don't understand it, come to light. And that's what I used when I was working at this firm doing digital transformation. And that's what I think that was the question was, right? Like what's actually needed to make this a successful endeavor. So I hope that I didn't rumble too much, but that I was to the point as to communicate, collaborate, gain technical knowledge, gain managerial knowledge, bring all those things together. That helps you be successful.
So I'll just quickly add, again, piggybacking on what John said, those are definitely all the soft skills that you need for a team to succeed. If you're thinking about a centralized repository, I think there was a question around, do we have a centralized repository if there are multiple data sources after you have standardized, brought things together? Because that is only half the work done, because you have been able to build something. Now, from a model risk management perspective, that's how I like to look at most of these data sources. Because as you have these data sources that you plan to use, you need to also make sure these don't turn stale over a period of time. What that means is you need to be able to monitor those. Are they being updated at the right time? So that what that means is a lot of data engineering skills, right? You need to be able to maintain these centralized repository, because the source data sources could be changing. They could be changing very fast at times. So these needs to be reflected in the central repository as well. So while we talk about all the soft skills, this is a hard skill, data engineering. And then the other hard skill, because we only talked about data that is actual data coming from different sources. Now we also talked about data generated from generative AI, which is a model. So model needs to be monitored in the sense that, is it generating the right data that you actually used in some sense in your organization? So that kind of brings in another skill set, which is ML engineering, right? So you need to be able to build these models, maintain these models, monitor these models. And then again, the data that is being generated needs to be passed on to that central repository if you plan to use it in that sense. So there is data engineering, there is machine learning engineering, and then there's an element of risk management. If you at all want to use these data sources, the centralized data sources that we are talking about, in some sense in your downstream models. So data accuracy, completeness, all of these needs to be maintained throughout, right? So there has to be documentation, governance, all the data governance stuff that you talk about. So it's not one person's job. It's going to take a team. That's how I like to look at it. If you are planning to build that central repository, which is housing data generated from different sources, that's how I would summarize my experience actually working for a bank where we actually built something like this, like a central repository.
Adding to the technical side of things, I like to call it soft skills, but I more like to call them, instead of soft skills, impact skills, because I think those skills that I mentioned at the beginning is really what get things done, right? That human side of things. And Dushan is right on the technical side, and I will add to that technical side. I don't know the details of the audience's level of expertise in data science, So apologies if I'm speaking to high level folks who have built deep learning models, or if you're a student, or if you are a mid-level professional that is getting to understand the technical side. But on the technical side, also understand that AI brings and generative AI brings a myriad and a combination of artificial intelligence models, right? And if you want to be technical, then you cannot really be a master of all those models. I mean, eventually, with the right time frame doing those models. But if you can just pick one or two types of models that you are great at, or you really like, then develop the expertise on that, on the technical side. So I developed expertise on 3 different types of models, like time series, recommendation models, natural language processing, because I think that's what applies to my subject matter expertise the most. And so I would add to what Deshaun is saying on the technical side, that really develop an expertise on 1 or 2 artificial intelligence models, because that would let you understand the rest of the models much easier when they come to you.
Good points. So we only have about 3 minutes left, and I did go back through the comments, and I think that we've hit on most people's questions. So I do think that we covered that. But just to close us all out, let's do a lightning round. And in a phrase or a few words, can each panelist just share one critical insight or takeaway about the future of generative AI in future engineering? If you have anything you want to comment there.
I will start. I would say, as a data scientist, the key word for me is research. It's research right now. Research. That'll summarize it for me. Do the work. Do the research. The research will tell you and give you answers when you're doing things.
All right.
My one word would be model operations. Feature engineering is one of the key components of the whole model operation. If you plan to use it, I think the operational side, once the things have been built, is as crucial as building something and maintaining, monitoring it. So I like to see that risk management side, because that's what I do day in, day out.
I was going to say risk management, but I'm actually magic. I don't believe that there is a such thing as magic, and this is not magic, and the next thing that comes along in 3 years is also not magic, which means that there's going to be drawbacks. There's going to be ways that you're going to need to control it so that it doesn't mess things up or behave badly, whatever. But also, when I say it's not magic, I mean, take the time to try to understand what's actually happening, and don't just treat it as I just throw this at the problem and then this comes out and it's solved.
Yep. Well, I'll close this out with saying leverage what you know, because I think Jessica kind of alluded to this when the next thing is going to come. Mm-hmm. And even though it may not feel that way when you start seeing these new things like, oh my gosh, we're at generative AI, you do get to leverage your prior knowledge, build off of that while you're learning the new thing, and it will help you kind of smooth the way for getting into the new thing. So leverage what you already know. A lot of people thought when we went to generative AI that we were literally throwing out everything else. I even had people come to me and say, everything else is null and void. You don't have to learn anything else. Now you've just got to learn Gen AI. Well, all of it works together. So leverage what you know. And so with that said, I want to thank all of our panelists. This was really an awesome panel and awesome discussion. The chat was amazing. I was trying to keep my attention between the panelists and the chats, but I think everyone was very involved and engaged, and it was amazing. So thank you, everyone. I hope this has been helpful and that you can leverage what you've learned here as you move into your respective jobs and experiences. So thank you.
Thanks.
Thank you.
Thank you.
Thanks, all of you. Thanks to our amazing panel for all of your great insights, Francis, Jess, Dushyant, and Jonathan. If you missed any of the webinar or want to rewatch anything, the recording will be available right after the webinar if you just refresh this page. And we thank you again to our partner, Data Robot, for making this webinar possible. You can start your 30-day free trial of Data Robot today by clicking on the link below. We'll see you guys next time. Thanks.
Thank you.
Thank you.